Today, let us look at prime factorization. Let us take a number 6 and look at its prime factors. We go sequentially, starting with the smallest prime factor. Let us take another number 20. Let us quickly prime factorize 20. Now let us try to find out the LCM and HCF of these two numbers, 6 and 20. Now let us write the prime factors along with their exponential powers. Now in order to find the HCF, we shall look at the factors common between the two numbers. So we see that there is a 2 common to both the numbers. It is interesting to note that the power of 2 in the HCF is equal to the smaller power of 2 from the prime factorization of both these numbers. Let us look at the LCM now. For the LCM, we shall take the common factor once and the rest of the factors as well. Note that the power of the common factor is higher this time. So the highest power of 2 is 2 here. So in the LCM, the power of 2 is also 2. Let us look at the product of the highest common factor and lowest common multiple. We see that it is equal to the product of 6 and 20, the two numbers that we started with. It is interesting to note that this result is true for all numbers. So HCF of two numbers A and B multiplied by the LCM of these two numbers A and B would be equal to the product of A and B. Let us look at a few problems. Find the LCM and HCF of 96 and 404 by the prime factorization method. Let us quickly prime factorize both these numbers. Let us write 96 as 2 raised to the power 5 times 3. And let us write 404 as 2 squared times 101. Now for the HCF, we shall look at the common factor and the smaller power of this factor. That would be 2 square. So the HCF is 4 here. Now for the LCM, we shall look at the higher power of this common factor and take the rest of the factors as well. So we get 2 raised to the power 5 times 3 times 101. We get 9696 as the lowest common multiple. Let us check if our answer is correct. So we could simply do HCF times LCM and check if it is equal to 96 times 404. There is another way to find the LCM of these two numbers. So we could use the property that the product of HCF and LCM is equal to the product of the two numbers. Let us substitute the HCF as 4 here and cross multiply, and we see that the LCM is equal to 9696, which is the same as the LCM we found out by prime factorization. Both the methods are correct. Let us look at another problem. Given that HCF of 306 and 657 is equal to 9, find the LCM of these two numbers. This time we shall use the property HCF times LCM is equal to product of the two numbers. Let us quickly substitute these values and cross multiply. Upon simplifying, we can find the product by splitting one of the numbers. We see that the LCM is 22,338. Let us look at another problem. An electronic device makes a beep after every 60 seconds. Another device makes a beep after every 62 seconds. They beeped together at 10 a.m. At what time will they beep together at the earliest? Now we have two devices. we see that one is beeping after every 60 seconds. So we are looking at multiples of 60. Similarly, the second device is beeping after every 62 seconds. So we shall be looking at multiples of 62 for recording the beep of the second device. Now, in order to find the time when they will beep together, we have to find a common multiple between 60 and 62. In order to find the earliest beep together, we have to look at the first such common multiple, also known as the least common multiple. So we are looking at the LCM of 60 and 62 seconds. Let us quickly prime factorize 60 and 62. Let us write the prime factorizations and write the prime factors with their exponential powers. Now to find the LCM, we shall take the common factor once with its highest power and the rest of the factors in the product. Upon solving, we see that the LCM comes out as 1860 seconds. Let us try to convert this to minutes. We know that 1 minute has 60 seconds. We get this as 31 minutes. So they beep together at 10 a.m. and they shall beep together after 31 minutes. That is at 10:31 a.m. So at 10:31 a.m. the devices shall beep together again.